Welcome to Poster CGN 29. I'm Dr. Lawrence Becker from Salisbury University, and this is my brief but spectacular take on how variable names affect the interpretation of graphed data. We've spared no expense. Okay. So for the past few years, my lab has been studying how students interpret graphs like this. This shows data from a research study with two independent variables, or factors, those factors being temperature and stress. And there's one dependent variable, that being fractures. So this is also known as a 2x2 factorial design, and this particular graph is showing an interaction between the two factors. Here is a graph presenting the same information as the previous graph, except the factor names have been changed to meaningless, or what we refer to as neutral names. Now the factors are simply labeled variable A and variable B. The question that interests us was whether there was a difference in how students interpret and process graphs with meaningful variable names versus meaningless names. In our study, participants answered a series of questions about 6 similar 2x2 interaction graphs. The independent variable was whether they were assigned to the meaningful graph or the meaningless graph condition. The two dependent measures were the number of errors made and the overall time for the session. So, meaningful versus meaningless variable names and measures of error and time. You can check our poster for the details of the procedure. Okay, so here are the results. This graph shows both dependent measures simultaneously. Time is shown by the blue bars and the left axis. Here we see that the participants took longer for the meaningful graphs, so meaningful graphs there, than for the meaningless graphs there. So this bar is higher than that bar. And this was a statistically significant difference between the two. Errors are showed by the slanted orange line and the right axis. So this is the orange line, and errors are shown here. Okay. Thus, for this measure, lower numbers are better. We see that participants made fewer errors for meaningful graphs, so fewer errors there, than for the meaningless graphs there. This also was a statistically significant difference. In summary, the graphs with meaningful names took longer to process, but resulted in fewer errors. Okay. To conclude, we believe our data suggests that students often use variable names to create a context or a story to aid in their interpretation of the graphs. Creating this story takes longer, but results in better understanding. As statistics instructors, we think this is a valuable finding and provides insight into teaching students how to interpret graphical information. Again, I direct you to our poster for further details, or please feel free to contact me directly at Salisbury University at lxbecker@salisbury.edu, right there. In closing, Drs. Clark, Tomko, and I thank our wonderful research students Victoria Barrera, Oluchi Danegwu, Meredith Hannes, Pauline Nsimba, and Abby Wiles, who all made invaluable contributions to this project. And by the way, each would be a very worthy addition to any graduate program. Thank you and enjoy the rest of the conference. As for me, I'm off for a virtual beer at the EPA virtual bar. Ciao!